is 6:02. I'm going to start the presentation today. Thank you everybody for coming to Water Quality Wednesday. So this is a joint open forum presentation put on by the County of Lake, Department of Water Resource Department, Public Health and Special Districts. And we have some special presentations today from two of our cyanobacteria partners, collaborators, I guess you would say, that are interested in learning and helping us learn about cyanobacteria issues on Clear Lake. So today's Water Quality Wednesday is titled Clear Lake Drinking Water and Cyanobacteria. And I'm gonna do a short, brief introduction, and then we'll get into our speakers. And my name is Angela De Palma Dow. I am I'm an invasive species program coordinator at Lake County Water Resource Department. I also write a column in the Lake County News called Lady of the Lake, and also manage some of our surface water quality programs. I'm very excited about today's Water Quality Wednesday, and thank you so much for joining us this evening on this Wednesday. I also want to shout out, thank you so much to the County of Lake staff right now. We have Matthew is helping us moderate today and operating the Zoom, and then we have Sam who's helping us make sure that this is broadcast to Facebook and on PEG TV. So thank you so much, staff, for staying late, 6 p.m. on a Wednesday to help us do this. And some reminders, this is a webinar. So we are gonna have a pretty good amount of chunk of time between the speakers for question and answer. You can submit your questions in the chat box below us here. You could also raise your hand during the break and you can ask a question that way and we can answer. But save your questions to the end. We won't be answering questions throughout the talks. And then just a reminder that this meeting is recorded. We want to be able to write it later so people can learn if they're not available right now. And we also have it streaming on our Facebook page, on the County of Lake Facebook page. The recording will go on our Water Resources Facebook page, which is at Lake County Water. And then we will have it on YouTube later. And we will have an evaluation link. We have one right now. I think Matthew's going to put it into the chat. Thank you, Matthew. And we'll give it to you again at the end of the talk. So we want to make these things kind of a regular thing. And in order for us to do that, we want to know what we can improve on, make better. So if you have any comments about today, about the presentation, about the format, about accessibility, make sure that you provide that information in the link. And if you're watching at home and you can't see that link, it is included in the post for the Facebook. And then we also provided it here. So if you're watching the video, you can pause it, write down the link, and then go do the evaluation survey that way. And we really appreciate it so we can be able to improve our outreach. And so these kinds of events are meant as kind of like a trial, figuring out if this outreach event is useful to the public, you guys, and also it's an accessible way to get water information out. So our goal is really to demystify lake and water science. We want to make sure that we're communicating about the people, the places, the programs, and the projects that are going on right now in the lake, on Clear Lake, and in the streams around Clear Lake, so you can be aware of what's going on and be interested. And that's because we all play this important role in protecting our valuable aquatic systems, right? We have to know what's going on so we can know if there's something wrong with it, and then we can fix it and manage these systems better. And I just want to take a quick moment to acknowledge the caretakers that came before us. So the First Nation original caretakers were Pomo here on this land, this ancestral land right here. And you've probably heard the phrase Lupioma, which is the creation story for Clear Lake. And then Clear Lake actually was called Big Water, referred to as Big Water, which if we look at the map on the right, this is an aerial satellite imagery. Clear Lake is pretty big, and so it's a very apt name for this body of water. Probably a lot better than Clear Lake, as we'll learn in this presentation today. And Big Water, I might not be pronouncing these right, but it could be called Hobbiton or Hokasha in Pomo, but I'm probably not pronouncing that correctly. But I did just want to acknowledge this land before us and this water before us, caretakers by the First Nation Pomo. So thank you. So our first speaker introduction, her name is Rachel Kennard. She's a Master of Science, recently graduated from UC Davis. She works as a source water protection specialist through the California Rural Water Association. And she has consulted with Water Resources on many projects. She's awesome, I love her, and I'm so excited to introduce her today. And with that, I will turn it over to Rachel, and you can go ahead and share your screen.
Hi, everybody. Let me get this shared. Okay. So thank you, Angela, for that introduction. Again, my name is Rachel Kennard. Today I'm going to summarize the research I did at UC Davis, which explores the impacts of cyanobacteria on drinking water sources. There's a lot to cover in this presentation, so let's go ahead and get started. To organize this discussion, I've put together a brief outline that will help us navigate through my research. For the introduction, I will introduce the term freshwater cyanobacterial harmful algal bloom, which I'll refer to as an FCHAB, the problems associated with them, and their prevalence in the US and in California. Next, I'll talk a little bit about the case study, which is Clear Lake. I'll give a general overview of the drinking water utilities that draw raw water from the lake and the economic classifications of the lakeside communities. I'll also talk briefly about water treatment processes in general so you can orient yourself with the topics. It will be important as we move on to the analysis section for you to understand general water treatment processes, but we won't go too far into the weeds there. Finally, I'll dive into each analysis that I conducted to discuss the results and conclusions. The analyses we conducted for this study are called risk analysis, microcystin percent removal analysis, water rate analysis, and chemical cost analysis. So with that, let's dive right in. The term freshwater cyanobacterial harmful algal bloom, or otherwise known as FCHAB, collectively refers to a proliferation of cyanobacterial algal biomass in fresh waters that have negative ecological, public health, or economic consequences. They can impact drinking water treatment processes, local recreational economies, and limnological food web dynamics. Not all FCHABs have the ability to produce toxins, but the ones in Clear Lake do, which is why I chose to use it as the case study. Toxin-producing FCHABs, like the ones in Clear Lake, may release potent neuro, hepto, and dermatoxins that can cause acute and chronic health effects in humans and are deadly to domestic animals and livestock. Removing FCHABs and their toxins from drinking water supplies is inherently challenging and expensive. It may require retrofitting existing infrastructure, adding new infrastructure, obtaining higher water treatment operator certifications, which we'll talk about later, and may result in increased operation and maintenance costs. When vulnerable communities are struck by FCHABs, it's likely that the ratepayers will be disproportionately impacted. FCHABs are expensive to treat in general, so the impact is going to be even more severe when communities are already classified as economically distressed, disadvantaged, or severely disadvantaged. Lake County is one of the poorest counties in California and has some of the toughest water to treat, which results in really high water rates, as I'm sure a lot of you are very familiar with. FCHABs, both the toxin and the non-toxin producing types, have been reported in a variety of habitats, including small ponds, slow-moving streams, embankments, drinking water reservoirs, and large lakes. FCHABs occur on a global scale. All continents, with the exception of Antarctica, have reported bloom events. In the United States, all 50 states have a state department dedicated to FCHAB management and response. Historically, FCHABs developed in naturally eutrophic, highly productive water bodies, such as tropical and subtropical lakes and slow-moving water bodies subject to high temperatures. In recent decades, however, more frequent and numerous FCHAB events are developing across the world due to climate change and environmental degradation. If there's any good news that can be taken away from this slide, it's that as more water bodies become affected by FCHABs, additional funding and resources will hopefully become available for vulnerable communities. You may feel that Clear Lake is the only place affected by these blooms, but you aren't alone. However, Clear Lake is a very unique place by California standards because, as you can see on this map here, most of the blooms are on the East Coast. There are several water bodies in California that seasonally develop toxin-producing FCHABs, but not all of them affect drinking water sources. For example, the New Melones Lake in Calaveras County, Lake San Antonio in Monterey County, and Lake Isabella in Kern County all develop toxin-producing FCHABs, but those reservoirs serve as flood control and recreational lakes that do not supply drinking water. The Salton Sea in Riverside County develops FCHABs, but due to the salinity of the water, is not used for drinking water purposes. FCHABs also develop in abundance in the Klamath River Basin, but the affected segment of river is considered wild and scenic and is not used for drinking water purposes. The South Fork of the Eel River in Northern California undergoes seasonal toxin-producing FCHABs, and there are 4 drinking water purveyors that draw raw water from the South Fork of the Eel River. The water systems currently have infiltration galleries that avoid the FCHABs. However, they are concerned that decreasing flow rates from climate change and nutrient loading from illegal marijuana grows in Humboldt County will continue to exacerbate eutrophication in the South Fork. Clear Lake, on the other hand, is a multi-purpose recreational lake that also serves as a drinking water reservoir and seasonally develops toxin-producing FCHABs. According to the available data, Clear Lake is currently the only reservoir in California with toxin-producing FCHABs. There are many drinking water systems affected by the non-toxin-producing types of FCHABs, but Clear Lake is the only one that has the toxin-producing types. However, conditions change all the time, so that may not be the case for very much longer. But right now, Clear Lake is the only one with toxin-producing FCHABs. There are 17 drinking water systems that draw raw water from Clear Lake. In response to FCHABs, they have implemented robust drinking water treatment systems. From this table, we can see that the treatment systems range from a treatment grade 2 to a treatment grade 4, with most of the treatment classifications being T3 and T4. Treatment grade classifications are designated by the State Water Resources Control Board. The classifications range from 1 to 5 in increasing order of complexity. Very simple treatment plants have a T1 classification, whereas the most complex treatment systems are classified as T5. So the fact that most of these systems are a T3 to a T4 show us that these systems utilize advanced technologies that have many steps in the treatment process. The cost to operate and maintain treatment systems also increases with treatment grade classifications. Higher grade treatment plants, like those in Lake County, require significantly more financial resources and highly skilled water treatment operators than lower grade treatment plants. Further exacerbating the impact of FCHABs in Clear Lake is the small number of connections that each water system serves. The number of connections is the number of houses or businesses in the system. The small number of customers limits the system's ability to spread the cost of water treatment over large economies of scale. For example, larger water systems can make significant infrastructure improvements on the order of maybe a couple of cents per customer, whereas the small water systems needing those same infrastructure improvements have a much steeper rate increase associated with those improvements. The cost of these robust treatment systems is distributed amongst a small customer base, resulting in high water rates for the local communities. The local communities are all classified as either economically distressed, disadvantaged, or severely disadvantaged. Therefore, the impacts of high water rates on these communities creates a disproportionate financial burden. Now, I want to quickly give you a general overview of surface water treatment processes because it'll give you some perspective on how complicated treating FCHABs are. If you have specific questions about treatment, we can address them in the Q&A section. In simple surface water systems like the one you see here, we have 4 unit processes. These processes are the backbone to nearly all surface water treatment systems. We call the processes coagulation or rapid mix, flocculation, sedimentation, and filtration. We then end the process with a disinfectant additive, most often a chemical called sodium hypochlorite. This simple treatment system is probably a grade 2, so it's pretty simple. But then there's Clear Lake, and this is more likely what you'd see at a treatment plant that draws raw water from Clear Lake. We have the conventional 4-unit processes at the beginning, but then there are so many additional processes that are added to battle the FCHABs. This isn't a real schematic for one of the systems, but it's meant to illustrate the range of processes involved with advanced treatment systems like those in Lake County. There are systems in Lake County that utilize on-site ozone generation, membrane filtration, granulated activated carbon, pre-oxidation, and other processes that rank their systems among the most complex in the state. With this in mind, you can see why treating FCHABs is so expensive. There are more processes, more maintenance, and more chemical additives. And just so you know, water from Clear Lake is widely known in the drinking water industry to be the most difficult water to treat in the state. It requires extremely smart operators and management staff. Some of the ways in which people learn about drinking water treatment, including how to calculate chemical dosages, originated in Clear Lake and are used nationwide. So if you want to kickstart your career and learn from the best of the best, join the water industry in Lake County. I can't think of a more rewarding job to have than to provide safe drinking water. It's got great job security too, because people are always going to need water. But anyway, with that out of the way, the introduction and stuff out of the way, let's talk about the analyses. The first analysis was the risk analysis. And the research question that prompted this analysis is, do toxin concentrations change with different inflows? In other words, I wanted to see if there was a relationship between high toxin concentrations and low water inflow into the lake. When I say inflow, that just means the water coming into the lake from the streams and rivers. Climate change is projected to bring longer and more severe droughts, so it's important to see if we can find any trends in the available data. My hypothesis was that as inflow to the lake decreases, it's more likely that we will see high toxin concentrations. So this graph is a little bit complicated, but taking it apart here, these are the results for the lower and the Oaks arm from 2016 to 2020. Along the x-axis here are the concentration ranges in microgram per liter. We have 0 to 0.3, 0 to 3.1 to 0.7, 0 to 7.1 to 1, and then greater than 1. And these are microcystins. Microcystins are a widely monitored class of cyanotoxins. We don't want to see values that are above 0.3 in the raw water, but we really don't want to see values above 1. So along the z-axis here are the 3 ranges of inflows that I used. And I have 0 to 30,000 acre feet, 31 to 75,000 acre feet, and 76 to 120,000 acre feet. 1,000 acre feet is a unit of measurement that's used frequently in the water resources world. 1 acre foot is the equivalent of 1 acre of land filled to 1 foot with water, or respectively 325,000 gallons. Along the y-axis here is the probability. So let's first look at the gray bars in the back of the graph. These gray bars represent the toxin concentration probability results for years when the inflow was highest, aka the wettest years. Nearly all toxin concentrations in this category of inflows were between 0 and 0.3, or non-detect and 0.3 micrograms per liter. And similar results are shown for the moderate winter inflow category, represented by the orange bars. So when the years were wet or moderately wet, most of the results are really, really low. But what we're really looking at for here is the results when the cumulative winter inflow is low. So what's going to happen in our drought years? When we look at the blue bars, we see the probability of toxin concentrations for our driest years. And in this category, there is an increased probability that toxin concentrations will be higher than 1 microgram per liter. So we still have some low detections, some non-detect to 0.3, but when we get into this category of above 1 microgram per liter, the probability increases. The overall goal of this analysis was to determine if and how toxin concentrations change in response to inflows. Our results show that decreasing inflows increase the probability of high toxin concentrations. Inflows are expected to decrease with climate change, causing more severe and prolonged droughts. Therefore, the implication of this analysis is that decreased winter inflow from climate change will exacerbate FCHAB development, meaning that this problem is only going to continue to get worse. Next, I did a percent removal analysis. I wanted to see if water systems in Lake County adequately remove microcystins to below 1 microgram per liter from finished drinking water supplies. I chose to use 1 microgram per liter because it's the World Health Organization guideline. Of the 17 utilities, 13 participated to varying extents in the voluntary monitoring program. The data in this set is from 2016 to 2020. There is now a mandatory monitoring program through the state that started this year in 2021, but this analysis does not include that data. All of the finished water samples in this analysis were below 1 microgram per liter. Finished water is like after treatment results. Therefore, based on the available data, the treatment mechanisms currently in place adequately remove microcystins to levels that are not known to cause acute or chronic health effects. The highest raw water detection was 31.3 micrograms per liter, and it was found at the Clear Lake Oaks County Water District's intake on October 30th of 2020. The highest finished water result after treatment was 0.7 micrograms per liter, and it was found at the Clearwater Mutual Water Company's intake on July 1st, 2020. 2020 was a really low inflow year, which helps to explain the high detections. So far, we learned that low inflows results in high microcystin concentrations. However, most, if not all of the surface water purveyors in Lake County have optimized their treatment systems to adequately remove high concentrations of microcystins. That's excellent news, but as water quality continues to decrease, the strain on treatment facilities increases, which, as we'll see in the next analyses, has an impact on the cost of water treatment. So to explore the cost, I conducted a water rate analysis. I wanted to know if FCHABs affect drinking water affordability. My hypothesis was that FCHABs create a disproportionate financial burden on ratepayers in vulnerable communities. We all suspected that this was the case, if you've looked at your water bill lately, but no analyses have been done to show the impacts of FCHABs on water rates. So this analysis presents new information and is tailored specifically to Clear Lake. Residents of the 17 surface water systems in our case study contribute an average of 3% of their gross monthly income towards water bills alone, which is double the recommended level of 1.5%. The residents who contribute the highest percentage of income are served by the Golden State Water Company's Clear Lake system at 5.63%. The residents who contribute the lowest percentage are served by the Richmond Park Resort at 0.92%. 15 of the 17 water systems that draw raw water from Clear Lake are above the recommended level for water affordability. This graph alone is shocking when you look at the difference between the recommended contribution and the actual contribution. But we didn't stop there. We did the same analysis for 2 other subsets of water systems. One subset of surface water systems that don't treat for FCHABs, and one subset of groundwater systems. All of the systems have similar connection counts and median household incomes as the ones in Lake County, which makes the systems truly comparable. The only difference here is the quality of the source water. So to exclude the possibility that surface water generally imposes a disproportionate financial burden on disadvantaged communities, a subset of other surface water systems in California that do not treat for FCHABs were evaluated using the same methods. The average percentage of gross monthly income devoted to water bills in these systems is 1.63%, which is only 0.1% above the recommended level. 50% of these systems in this sample set are at or below the recommended level of 1.5. For comparison, the highest result in Lake County was 5.63%, and the highest result for this set is 2.47. These results show a staggering difference between the cost of surface water treatment with and without FCHABs. If you'll notice, the cheapest water in this subset is Spring Valley, a water system located in Lake County. This water system doesn't draw from Clear Lake and is not subjected to FCHABs. So the cost of water treatment isn't just a Lake County thing. It's truly the cost of treating FCHABs that drives the water rates. Similarly, this analysis was repeated for a suite of groundwater systems. The average percentage of gross monthly income devoted to water bills in this suite is 1.45%, which is just below the recommended level of 1.5. 72% of these systems are at or below the recommended level. When comparing the results between these three sample sets, we see that Clear Lake systems contribute a significantly higher proportion of their gross monthly income towards water bills. Therefore, the results of this analysis show that there is a disproportionate financial burden on disadvantaged communities treating for FCHABs. So we're really starting to gain momentum here telling this story. We know that climate change will continue to exacerbate FCHAB conditions in eutrophic water bodies as seen by the risk analysis. We also know that water treatment systems in our case study are doing an excellent job of removing microcystins from finished drinking water supplies as seen by the percent removal analysis. However, the cost of treating FCHABs creates a disproportionate financial burden on ratepayers in vulnerable communities, as seen by the water rate analysis. In the chemical cost analysis, we see a direct relationship between the cost of water treatment and FCHAB events. Here are the results. This is data from one of the surface water systems that draws raw water from Clear Lake. Remember when we talked about chemical additives? Well, when blooms occur, water treatment operators have to add more chemicals to treat the water. When more chemicals are needed, the cost of water treatment rises. I wanted to see if there was a correlation between the cost of water treatment and bloom season. So we see here that the chemical cost of water treatment per unit of water produced increased during the mid to late summer, which is represented here by Q3. So this is Q3, mid to late summer, which also corresponds to the months when FCHABs are present. As climate change and environmental degradation continues to degrade water quality, seasonal water treatment costs will increase and vulnerable communities will be further impacted by rising water rates. So to summarize, here are the findings of our study. We found that low inflows into the lake increases the probability of high toxin concentrations. We found that systems in Lake County adequately remove microcystins to below the World Health Organization guideline of 1 microgram per liter. We found that FCHABs create a disproportionate financial burden in vulnerable communities. And we saw a direct relationship between the cost of water treatment and FCHABs. And although the results of this research paints a rather grim story, there is a ton of work going on the county and at the utility level. There are grant applications out there. We are working on source water protection measures, and there are outreach measures like this in place that are aimed to alleviate the disproportionate financial burden of Clear Lake surface water. So it's not as grim as it seems. And here's my contact information. I hope you found this presentation informative. Thank you very much.
Thank you so much, Rachel. That was amazing. You did such great work. I will just mention too that Rachel doesn't live here and she still cares so much about Clear Lake, and I just love that. And so right now we have about 6 minutes for questions and answer. So if there's anybody have questions into the chat, we'll see. Matthew, did anybody have any questions submitted? I didn't see any right at first glance. And then other than that, if someone wants to raise their hand as well, we can take questions over the line too.
At this time, no questions have been received via the chat and no hands are raised.
You did such a good job explaining everything. Good job, Rachel. Okay. Looks like we have one question or raised hand. Sarah. Let's see, can we unmute you?
Hey, it's unmuted. Yes, I wanted to give Rachel an opportunity to say where she got her data from.
Thanks, Sarah. Yeah, absolutely. I should have put some acknowledgments here at the end. I got all of my data here, all of the microcystin data from Carola Kennedy. She was the one who was administrating the voluntary monitoring program. And so special thanks to her, because I would not have been able to do any of these analyses without her. Thanks, Carola.
Thank you, Sarah, for that question and that point. We do have a question in the chat from Kay Peterson asking, said, great presentation, thank you. And is there a reason research didn't look at in situ treatment in Clear Lake, either chemical or non-chemical, like ultrasound? Do you know of any comparisons or studies looking at this?
I can partially answer that question. The reason why I focused so much around the drinking water utilities is that's what I do for work. And so if we were going to do in situ treatment, like, and Clear Lake as a whole, that would be something that would be coordinated, I would believe, through the county and other stakeholders that are involved. But I was just looking on the perspective of the ratepayers and the physical treatment methods that the drinking water utilities are using. Though I do know there are several mechanisms out there like ultrasound, which I think could prove to be useful, but at the same time, this is a recreational lake. And so it might be a boating hazard, or those instruments could get damaged in some way. There are also bubble curtains and destratification work going on. UC Davis under Jeffrey Schledo is doing a lot of work to research destratification and aeration in Clear Lake. But I'm not under him. I was under Professor Sandoval Solis. Angela, do you want to add anything to that?
Yeah, I was just going to say, so the research that Rachel mentioned in Jeff Slato's lab, they're from UC Davis and Turk, the Tahoe Environmental Research Center. So that's part of the ongoing Blue Ribbon Committee efforts. And if you want to know about what's going on, they do reports every 3 months. And all the information, their annual reports are available online. And we'll drop right now in the chat how you can get on that listserv, so you can both get access to the Blue Ribbon Committee events or things that are coming up, as well as get information about where their website is, and you can get access to all the previous meetings. There's some recordings and videos where you can look at Jeff's presentations and some of the other students' presentations. I will say that Clear Lake is a really big lake. So features like ultrasound, or there's other kinds of things like sound waves. There's all these experiments that work great in the lab, and then they bring them out to like a smaller pond or like a man-made reservoir that's smaller. When you have that scale issue of such a big lake like Clear Lake, sometimes things don't always work that well. But part of the Blue Ribbon Committee's efforts is to kind of figure out what exactly is the problem is, and where would be the best place to put some of these in-lake things that might have an impact on both blooms for recreation. People are swimming and boating and fishing and recreating the lake too. There could be exposure that way, but also for having a positive impact on water around where drinking water intakes are. So it's a complicated issue. I think, having the treatment information for the drinking water and then the lake treatment and management is two separate things, obviously very much linked. So thank you, Matt. Yeah, he put that information in there. I hope that answered your question. Kay Peterson, and then are there any other raised hands? Any other questions? We have 1 minute before Sarah's presentation. The one thing I would like to ask a question if we don't have one. Is there any questions, Matt, that you can see?
None that I can see.
Okay, thanks. You did mention about inflows, Rachel, in your talk. Can you describe a little bit about those? You talked about climate change having impact, and then inflow being an important component of what you're saying with the relationship with increases in microsystems. How exactly are those things linked?
Yeah, so they're not fully 100% directly linked. Like if you have low inflows, you could not see high toxin concentrations because there are so many things that go into the development of an FCHAB. There are things like temperature, and there are things like the lake level, the previous precipitation. There are like the internal nutrient loading, the external nutrient loading, how much is in the lake, how much is getting, the nitrogen is coming into the lake from the atmosphere. There are so many different things that are driving blooms, but what we found is that they're at least partially driven by how much water is coming into the lake. And so in these severe drought years, it is more likely that we're going to see these high toxin concentrations. And as climate change gets worse and leads to longer, prolonged droughts, we will likely see very high toxin concentrations.
Great. Thank you so much, Rachel. Really appreciate it. Great talk. We're going to go on to the second speaker now. We will follow up with another question answer. So if you did think of a question for Rachel, we can also talk about it in the second question answer section. And right now I'm going to introduce Sarah Ryan. She is the Environmental EPA Director at Big Valley Rancheria. And she is also a co-chair for the California Cyanobacteria and Harmful Algal Bloom Network. It's shortened as FCHABs, these nice fun acronyms. She also manages the Clear Lake Water Quality Facebook page. If you guys are on Facebook or you want to get, up-to-date current water quality information, I would suggest following this page. She does report all of her monitoring results with photos, field photos, which we love, that we can actually see what's out there on the lake and then what do those means in real-time results. So we really appreciate that. So thank you, Sarah, and go ahead and I will stop my screen. You could go ahead, share your screen. And you're gonna be talking about your Calwatch program monitoring private intake. So before we were talking about public intakes, Rachel was talking about those. Now we're gonna be talking about some private intakes as part of a project that Sarah's been doing.
Hi, can you see my Calwatch program slide?
It's still in the non-presentation form, but I can see it.
Okay,
So make it a slideshow.
How about that?
No. Maybe it's on the other screen. It's also your update. Update your Microsoft. I can see that.
Okay. I'm sorry. Let me stop my screen.
That's okay.
Share screen. Oops. Sorry about this. I've only done 1 million of these, right? Okay. So I'm going to move it to screen. I'm going to share screen 2. That's what I'm going to do. Okay.
Screen 2, I think, is good.
Screen 2. And I'm going to move this.
There we go. Tribal beneficial. Oh, Calwatch program in Clear Lake. Perfect.
Yay. Okay. Are all these little doodads out of the way? Okay.
Yeah, you're good.
All right. Thank you. Nice to see you all online. I see a few names I recognize, and I absolutely understand the interest in this topic of, the different uses of Clear Lake, especially the drinking water side of things, and some of the water quality issues that we have. The Calwatch program that I'm going to talk about tonight is a program that Big Valley has recently gotten involved in and helped create. And we are partnering with Tracking California, which is part of the Public Health Institute, which is part of California Department of Public Health. They're all linked. So, and this is connected, we're doing more than just cyanotoxin monitoring. We're doing a few other contaminants as well. So hopefully you will learn from this presentation and enjoy it. So a few acronyms. Calwatch actually is a cool little acronym standing for California Water Assessment of Toxins for Community Health. It really is Clear Lake focused because it was, as I said, a project that multiple people and entities came up with. The collaboration with Big Valley, we are basically the boots on the ground for Tracking California to do the monitoring and to develop the whole program. And also, I just want to explain FCHABs, which is the One Health Harmful Algal Bloom System, and that is the effort that is happening nationally to be able to report cyanotoxin illnesses, whether it's human or animals, and just have a more standardized overlook and overview of illnesses. So the Calwatch program that we are almost about to start year 2. The principal investigator is Gina Solomon, whom some of you might recognize from Cal EPA, but she's now with the Public Health Institute. As I mentioned, we have Tracking California. Our team is also Big Valley, of course, the State Water Resources Control Board, the Drinking Water Division, and the Office of Environmental Health Hazard Assessment, which is part of Cal EPA. It is a CDC-funded grant. We are just got funded for the 2nd year, just about to start that, and it's a 5-year program. You can see the funding there. Big Valley didn't get all at $290,000, but we got a nice little chunk of it to be able to do the amazing amount of work that we're having to do with this project, which we love. It's very helpful. We have 4 components. It's part of the CDC requirements. So I just wanted to list kind of the components on there, but I'll explain each one. So component A is capacity building. That is really larger than Clear Lake. It's statewide. And so the reporting tools, as you as you know, in government, there's only so much money to do things. And often what gets left behind is the tracking or documentation or compliance assistance efforts and things like that. And with illnesses and with cyanotoxin illnesses, this was something that was really important to the, especially the Tracking California team, that there was enough funding to be able to make sure all the numbers were in there, to do this amazing amount of outreach that they're doing statewide to all the water bodies that are testing for cyanotoxins, or there are illness reports that are coming in. And so there's some additional funding just to help with capacity building. Component B, B3, has to do with the Clear Lake beaches and harmful algal blooms. And some of you have might have participated in our beaches survey, and I'm going to talk a little bit about that. We've had hundreds of people participate. It's been fantastic. And we had an insight going out to some of the public beaches a few weeks ago with our part of our team from Tracking California and the water boards in OEHA. It's on, the survey is going to be ongoing until it's almost over actually, but we've had hundreds of responses from online and also from in person. And what we're asking people in the survey is, are they, have they heard about harmful algal blooms? What kind of uses do they have on Clear Lake? Do they, they just come up periodically? They live here, and what are the ways that they use Clear Lake? And how are those uses impacted by harmful algal blooms? Who do they trust getting information from, and how would they like to see it in, more better information put out there? And I was really surprised, but in the hundreds of responses we've gotten thus far, the people are asking for more nixles. They want to see nixles on cyanotoxins. So I knew that was a sticking point a couple of years ago. It was like nobody wanted to do that, but actually the public would, at least the ones who've responded, would love to see that from from our groups. So just FYI. The beaches and harmful algal blooms component also is giving us some funding to do cyanotoxin monitoring during illness reports. So when there's someone is reporting to public health that they're recently feeling sick or their animals have gotten ill, there is a communication network that happens with County Water Resources and Angela, the public health folks, the public health officer, and Big Valley, OEHA, there's a bunch of us that are in there. And usually, and because of this funding, Big Valley is actually funded to go out and take the sample, get it to the lab. We do microscopy. We usually do a Braxis on it as well, just to get some in-house testing for the toxins. And then we submit it, and it's all done in a very coordinated way. And there's just a lot more information that's collected than there has been in the past. So that is part of the component 3, B3. And component B1 and B4 is probably why you guys are here. So it's the drinking water hazards at Clear Lake. So we're focusing on the near shore wells that started at 50 feet when the lake level is high. Okay, so now we're talking like 100, 150 feet for a lot of these wells. But near shore wells, and also the homes that have direct lake intakes. And there are hundreds of them on Clear Lake based on our research. So these are folks that are not on public water systems, so residences, but small businesses are okay too. But they have to be pulling from the lake or have those wells that are right next to the lake. And we do ask the people who are eligible to do a health questionnaire, a health status survey, and fill out a consent form and just a little bit of a hoops they got to jump through, not too much. And what we're doing is a one-time free water testing of nitrates, coliform bacteria, which includes total coliform and E. coli. And this is all of their tap water. Cyanotoxins, if there is a bloom present near where their intakes or well is, and also herbicides if they have been used near where their intakes are or where their well is. We are also doing, with these two components, a general health education about safe water practices, and we've created some evaluations, some resource lists, and also evaluations for the program. So within the CDC grant, they do call these private systems very small community water systems. So the project basically was identifying locations using the water boundary tool to eliminate those homes that are on public water systems. We're conducting water sampling, doing outreach, targeted messaging for individual households that are participating, communication of the risks, and we are going to be doing that. We are sending out results already. Of course, But we are doing a webinar at the end of this, and also reporting to health authorities information that we have, either in a general or more specific way, depending on whether the participant has granted permission for that. And we're doing mapping and data management. So the nearshore wells, as I mentioned, are wells that are within 50 feet of the shoreline, and they are at risk for intrusion of contaminants from the lake. So we figured between herbicides that are used near them, cyanotoxins that are nearby, and other water quality issues, that the wells, our premise was that they would potentially, especially if they don't have good treatment systems, would potentially see some of these things in their tap water. And private wells are not regulated or monitored. Those are, so who's allowed to participate in this is 1 to 4 drinking water, or 1 to 4 connections. And we actually have a few groups of people who are hooked to one main well that goes to 2 or 3 other homes, and they are participating in this. But intakes or wells that are connected to 5 to 14 homes or service connections, those are regulated by environmental health. They do have to meet some aspects of the Safe Drinking Water Act, and those that are 15 service connections or above are regulated by the State Water Resources Control Board, Drinking Water Division, and they have to meet all parts of the Safe Drinking Water Act. But these private wells and intakes do not have to meet the Safe Drinking Water Act. And so some of them might be renting out their homes or have renters in there or live there full time, and they don't really know what's going on with their water quality. So that's the same with the intakes. So we can see on this map that these purple shaded areas are the service areas of the 18 surface water, public water systems that are on Clear Lake, that pull their water from Clear Lake. And they serve approximately 62% of the county residents of the population of the county. But everybody else who is on the shoreline that have homes there are getting their drinking water from wells or very small intakes into the lake, and that's approximately 600 properties. So I've highlighted in red some of the areas that are, when we were doing our evaluation of which ones are eligible, we had a very, a zoomed in level, and we're able to get, of course, all of the contact info from every single home that is not on a public water system on the shoreline. So we used a process of elimination and started to reach out to all of these folks, and there were hundreds of them. So in the B1 and B4 part of this grant, we did do outreach to homes. As I mentioned, we identified who were eligible and started to send them information. We did outreach on social media. We did lots of mailings, and I have a slide about that. And so the outreach to participate is one big component. The next one is to report those results to the participant. We are sending the actual lab results, not some summarized thing, but the actual lab results, and then some additional information to help them out, help them understand what those results are. And if there are contaminants present in their tap water, then we are advising steps for them to protect themselves more. And there's a lot of extra projects that have sort of come from the results that we've gotten thus far. We started in February, so we're quite a ways into this. But we have some next steps that we're going to be following up on that I'd be happy to talk about at another time. And then, the community level reporting, it's really important to know what's happening kind of lake-wide for all of our households that get their drinking water from Clear Lake. It's not something we've been able to really identify before. So having that information is helpful for, I think, the county and the state and the tribe. So if you go into this Calwatch URL, you'll see this kind of intro slide that gives a description about our program and what we're testing for and who the participants are. So highly recommend you go to that and just find out more about our program. And here's just a little bit about the Beaches survey. We did put this out on Facebook, as well as handed these out. These posters are hanging in various locations in the county, and we're also doing social media to encourage people to get on this link and take the survey. We've had, as I mentioned, I believe we're over 400 people thus far. So it's great, and we can't wait to show the results. It's really interesting stuff. Very helpful to know. So here are the numbers of who we've reached out today. So we did identify 493 eligible addresses that had homes or structures of over $10,000 value and that were not hooked to the public water systems. We did send out postcards to all these homes. We did a lot of social media outreach. We actually went door to door to hang up door hangers and also mailed packets to them so they could just sign up online or sign up in paper. And we've had we've had over 100 respondees, but about approximately 50 of them are actually really eligible. Because some folks are finding out online and they want to participate, but they're actually hooked to a public water system. So we connect them up with their public water system. So so as I mentioned, we're doing total coliform, E. coli, herbicides, nitrates, and cyanotoxins. So I want to get into the herbicide aspect of it. So these are two maps that we received. So we work closely with CDFA and the County of Lake to find out exactly where herbicide treatments were happening on the lake. And we connected up these large-scale mapping areas from CDFA, and also this very helpful map from County of Lake, and looked at our participants' mapping and reached out to the participants and asked them if they would allow us to test their tap water for that particular herbicide to see if it was present in their tap water. And we did that within approximately a day of the treatment. And there were only 3 households that we were able to organize that and schedule it. And all of them came back non-detect for fluoridone. That's what we tested for because they were all close to the fluoridone CDFA treatment. But really helpful to know, and we're going to continue that for next year. But good to know that those 3 had no detective fluoridone in their tap water. We're also testing for cyanotoxins, and I'm showing the map of our recreational. We're into our 8th year of recreational cyanotoxin monitoring. This is a map that we put on our website of the different testing areas and what the results are. And this is the most current result. There's quite a few dangers in the Oaks and lower arm. And so if we have participants in this area, which we do, so I can tell you the whole kind of Windflower Point, this whole peninsula, most of those homes are on intakes. And there's certainly other areas in the Rivieras and in the Soda Bay area, some in Lucerne and outside the Glen Haven area. So as I mentioned, hundreds of homes that are actually eligible to be tested and to participate in our program. So we have reached out and we actually got some additional funding from California Department of Public Health to do a second round or to do an extra round of cyanotoxin monitoring with the tap water. I do want to say that when we do reach out to people, we ask them what their treatment is. We ask them, if they have maintenance company come out and change their filters. Some folks don't understand what their tap water, how it's treated. Some folks actually don't even have any treatment with their tap water. A lot of people say, I don't drink the water, but they do shower in it. I've had some people say, I don't drink the water, but I make coffee with it, I boil our pasta with it, brush my teeth with it, and I take a shower with it. So I'm like, okay, so kind of drinking the water. But most people have some sort of treatment, whether it's chlorine, filtration, RO, some folks have RO. So we note all of that down, and when we are testing, we are taking all of that into account. So we do have a lot of documentation and tracking that we're doing, but I did want to do a screenshot of one of the tracking or one of the sections where we're, took notes of what their treatment is. And you can see like a lot of different kinds of treatment. We are doing a chlorine residual testing of their tap water. And you can see a lot of people have 0. So they don't have any residual in their tap water. And if they don't have an RO system, they really should have a residual at their tap. But many of them have a very, very low residual. And so what it showed to us was that they've got to understand the need for that. So some of our outreach has been about and will continue to be about the need for proper levels of chlorine, but also to better understand their treatment system. So as I mentioned, we've learned a lot about the different treatment systems that are on the lake. A lot of people do get help from maintenance companies, but it's really, you'll see from some of the results that it's just not enough. These treatment systems are not really working. So out of the 40, and this is a little bit dated information, So we've had some additional results and sampling since this little thing I put together. But out of the 44 homes tap water that we tested, 30 of them were intakes, 14 were wells. 45% or 20 of those had total coliform in their tap water. They just had a presence of total coliform. 6.8% had E. coli present in their tap water. 20% had nitrates present. And the highest was, I believe, about 7, which is I think it's parts per million, and 10 is the action level. So getting up there. Out of the 28 that we had tested for cyanotoxins, 57% had cyanotoxins at their tap water. And out of the intakes, and all of those were intakes and not wells, so that was really interesting, 89% of the intakes had cyanotoxins present at their tap water. And that was really surprising. And even more surprising was that they had cyanobacteria in their tap water. So that means that the cyanobacteria, and this is actually a picture from today from a system that we tested just yesterday. And this person had an RO filtration and RO treatment at their tap, which they thought was working. Obviously is not when you have intact cyanobacteria. It's going through your pumps, going through your chlorination, going through your holding tanks and your other treatment and your filters and through your RO system. And here's what's coming out of your tap water. The highest toxin level we've had come out of in the tap is 3.85 micrograms per liter. The US EPA recommends, the health advisory is at 0.3 micrograms per liter. So you can see it's over an order of magnitude higher than what's recommended for safe drinking. And that is for any households that have children under 6. So that's really kind of recommended to be, that is the number that US EPA recommends. I know Rachel said 1 for the World Health Organization, but the health advisory is a different thing. And that's really based on health and not any economics, not taking anybody's money into account. It's just what should it be for health purposes, 0.3 micrograms per liter, and the highest is 3.85. Most of the homes that did have cyanotoxins in the tap water were above that 0.3. So,
hey, Sarah, I just want to make you cognizant of time. We just have a couple minutes left, so.
Oh, perfect.
I just want to make sure it's like, I just want to make sure that you finish up, and then we can have a really quick time for question and answer. But thank you. This is great stuff. So just want to make sure.
Okay. I just have a couple slides left. Thank you for that. So we are sharing information with all of the participants. We're still open to take new participants. I want to give you, and as I mentioned, we're starting communication with the treatment system companies regarding the results. And the need to treat for cyanotoxins, because that's obviously an issue. We're also working with environmental health and OEHA about risk and communication. And I just want to I had a few screenshots of some of the results that are coming out, or how we're communicating it to folks. So you can see right here, it's a little bit small, but we redact everybody else's information and just show them theirs. So here's a particular home that had had nitrates present. And then we're communicating, hopefully in a relatively simple manner, what does nitrates mean? What does coliform mean? In this particular one, this is communicating to people. They have total coliform present, but not E. coli. So we give some recommendations of how they should manage that. Certainly for the ones with cyanotoxins in their tap water, definitely above the 0.3, we are communicating to them that they should not be drinking that water until they've had it tested again and had it properly maintained. And this is something, recommendations that are coming out from the water boards. So that's basically it. If you have any questions, you can always reach me later, or there's probably a minute or two right now. So thank you very much for the opportunity to speak on this.
Thank you, Sarah. That was very good. You wrapped it up. So I just, there's any questions for Sarah, and I'm going to put the contact information up for all 3 of us. So I'll put it up for both speakers, Rachel and Sarah here, and myself, in case there's any questions or anything talked about today or related, or questions or any concerns. And then make sure that you also, if you can or able, fill out the evaluation form, the link that'll go into the chat here. It's in the chat box. Matthew is going to put it back in. And then if there's any questions for Sarah, we're over a little bit, but I think that's fine. If you're interested, we want to be able to provide information for you. Thanks, Matthew. And then do we have any? I looked on the Facebook and there's nothing there for right now. Questions? Do we have any raised hands? Any questions with Sarah? I don't see any. Matt, I don't see any questions. Is that correct?
I'm getting off
no
easy,
hands.
Angela.
I know. I was like, you provided so much information. It was so good to see results. And I know this is an ongoing project.
Yeah.
It's really cool right now. You guys are presenting stuff that's novel. We've never had both of this information together and on Clear Lake before. So having the well information, the private intakes, as well as the water rate information for the public systems and impacts of cyanotoxins and cyanobacteria. It's just great to have this wealth of information together in one spot. And I thank you guys both so much. I'm going to give one more moment if there's any questions still. While you guys are both here, again, thank you so much for giving up your Wednesday evening to share your work with us. And hopefully we'll be able to keep going with the Water Quality Wednesdays and maybe follow up on some future research in the future with this. So one more chance. Anybody questions? Okay, thank you. Well, the contact information's there. The evaluation link is in the chat. We really appreciate you guys giving up your Wednesday here, both to the speakers, to the staff, Matthew and Sam, for being able to moderate and make this webinar accessible online for us. We could all stay safe. And I hope you guys all have a really good week. Reach out to us if anybody has any questions about water quality, cyanobacteria. And thank you again so much to the participants and to the panelists and the staff. Thank you guys so much. I hope you have a great week.
Bye. Thanks, Angela.
Thank you.